The journey of a continuous ribbon of light begins not as a strip at all, but as a dense constellation of microscopic LEDs. Here, a single silicon wafer holds thousands of individual light sources, each one being precisely mapped for assembly. This state-of-the-art facility is where the complex process of manufacturing flexible LED strips takes place. First, a silicon wafer containing thousands of individual LED chips is mounted onto a sticky blue film and stretched taut within a metal ring. Excess film is trimmed away, and the prepared wafer is labeled for tracking through the production line. Inside the automated machine, a high-speed camera scans the wafer to map the exact location of each individual LED chip. Rows of these sophisticated machines work in unison, rapidly picking and placing the tiny components onto flexible circuit boards. The populated strips then move into a buffer system before the next stage. Next, the strips travel through a long reflow oven, which heats the solder paste to permanently bond the components to the board. After cooling, an operator lays out the long strips for a thorough quality inspection. A specialized jig illuminates sections of the strip, allowing the inspector to check for any malfunctioning LEDs. If a defect is found, a skilled technician uses a microscope and precision tools to carefully replace the individual component. Once the strip passes inspection and any necessary repairs are made, it's wound onto another reel. A worker prepares a mixture of phosphor and silicone, then seals it in a pressure pot for the coating machine. This machine will now apply a uniform layer of the phosphor mixture, over the surface of the LED strips. After passing through a curing oven, the phosphor coating solidifies, and an operator removes the finished roll. The rolls are then placed in a baking zone for a final, high-temperature curing process to ensure durability. A technician loads the spools of LED strips onto racks inside one of the industrial ovens. An automated process applies a strong, double-sided adhesive tape to the back of the entire strip. The strips are then run through an aging test, where they are left on for an extended period to check for any potential failures. Next, the strips move down a long assembly line where workers will attach the power wires. The cut strips are bundled and prepared for the final soldering stage. Each station along the conveyor is dedicated to a specific part of the final assembly process. Once the wires are attached, the completed strips are moved to a large testing rack for another comprehensive burn-in test. On the final assembly line, workers meticulously perform the last quality checks and packaging preparations. A worker tests a final strip one last time before carefully winding it onto the retail reel. The high-speed winder ensures the strip is packed neatly and without any kinks or damage. The completed reel is removed from the winder and placed in a bin, ready for boxing. A final inspection ensures the product is perfect before it is sealed for shipment. The finished product is used in a vast array of commercial and residential applications, from signage to architectural lighting. Its flexibility allows for creative installations, like this infinity mirror display. Different models are available, including ultra-thin strips that can fit into narrow channels.